Welcome back, or thanks for being here. If you happen to click on part 2 first, this is part 2 of our 1.4 reasoning and proof lesson. It was like 15 minutes and it was getting a little long, so switching it up. We are going to hop right back into this. So we learned about inductive, deductive. We talked about some conditional statements, if this then that. So if you watched part 1, then you should be watching part 2. Here we go. Postulates. Postulates remind me of, like, I don't know, something to do with the heart or something. So here's explain number 2, using postulates about segments and angles. So we've talked about line segments, we've talked about angles, we've done some things. So there's some vocab here that I need to make sure that you guys know. So supplementary angles, just any two angles that add up to 180 degrees, so they make a straight angle, straight line. The following theorem, though, shows that we have something called a linear pair. So a linear pair is a pair of adjacent. Do you know what adjacent means? Like when you're right next to somebody, adjacent. Just kidding, like Jason. I shouldn't have referenced him. I don't like Jason Kidd. He's not a good person. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. Sometimes you can get bogged down in the math verbiage, so make sure that we figure out what that means to us. Non-common sides are opposite rays. So here we go. The linear pair theorem, there's an R in there. If two angles form a linear pair, then they are supplementary. In a conditional statement, if and then. So if they're if they form a linear pair, they have to be supplementary. So you could say that all linear pairs are supplementary, which is what we've learned already. And then we have our angle notation. So the measure of angle 3, which is there in blue, and then I'll do the measure of angle 4 in red. We're saying that the angle measure of 4, the angle measure of 3, you add them together, you get 180 degrees, which makes a supplementary angle. There we go. Make sense? Hopefully. If not, maybe watch that again. Ask me a question. Shoot your shot. So we can use the linear pairs and the other postulates we have, the segment addition, the angle addition, to find missing values. So the whole purpose of this, guys, is to do stuff with it. And hopefully I do a good job of setting you up to do that, because otherwise it's kind of just like out there. So here we go. We have a couple things to look at. We have RT. And RT is a line segment. So this is RT, right? And what we're saying is that the line segment is equivalent to 5x minus 12, and that's noted. If we look at the segment addition postulate, we know that RS has a length of x plus 2. It's given. We didn't have to do nothing to find it. We said to look. Open your eyes. And ST, the line segment ST, is equivalent to 3x minus 8. That's the length. Well, if you add those up, which is what they're going to do here, because we're using the segment addition postulate, which says that if you add two segments, they make the length of the longer segment. You add them up, you get 5x minus 12 on the other side, because that's what we said RT was. So we do the math. Combine like terms, solve, and you get x equals 6. We were able to do what we wanted to do, which is find the value of x. So that seems like, to me, it always seems like I'm doing extra, and honestly, it probably will. I'm sure that's how, like, people that are proving things, and scientists and stuff, feel. But that's what we're doing. So let's take a look at the next one. So angle measure of RST is equal to 15x minus 10. Do you guys know what that little is? It's a degree. So we're talking about degrees because that's how we measure angles. So you take a look. We're going to use what postulate? So we know that there's a postulate, and it's the angle addition. We talked about this before. Angle addition. All right. The measure of RST is equal to what? Well, we don't have RST as one angle. It's composed of multiple. So what angle is this? You guys remember how to name angles, hopefully. So do it real quick. Pause me and then come back. We got RSP. RSVP. And we have PST. Now you may have slightly different naming conventions, but make sure that S is your vertex. It's in the middle. So we know that the whole thing is equal to 15x minus 10. So what are the parts? Check your parts. X plus 25 degrees. I'm going to not write the parentheses now just to not make a mess, but you should write them there the first time. And then 5x plus 10. So what we want to do is we want to find x. Anytime you see a variable, we got to find it because it's unknown. We don't know what the value is, and when you know the value, it lets you get the actual thing, like what is the actual measure of this angle, so you can, use that to your advantage for something. Let's do some math. Combine like terms Clt, and again, you can definitely do all this on your own. X plus 5x is 6x. 25 plus 10 is 35. Make sure you're with me. Then what I would do is subtract 6x. I don't like how, that's why one of the reasons I don't love the book, but so I would probably just do it over here. Do your work however you do it. Subtract 6 on both sides, 6x, you get 9x. Add 10 on both sides, you get 45. Michael Jordan. Divide by 9, and you get 5. So we know that x equals 5, but what does that tell us? Nothing unless we do something with it. So what we can do to figure out what this whole angle measure actually is go substitute it back in. So 15 times 5 minus 10. 15 times 5 is, break it up, 5 times 10 is 50. 5 times 5 is 25, that's 75. Minus 10, 65 degrees. Which matches our diagram because that's an acute angle. You're welcome. All right, let's keep moving. So little time for reflection. Take a look in the mirror. Linear pair theorem uses the term opposite rays, adjacent angles. Write a definition. I think this is cool. I like problems that make you guys write things in your own terms. So pause and try it. Basically, an example that you could put is opposite rays are rays that share a common endpoint and form a line. So think about what that would look like. They make a line there. Adjacent angles in the same plane. So common vertex, common side, but there's no common interior points. Adjacent angles. You might have put something else. I'd love to hear in the comments what you put. I feel like my pace is kind of weird on this video, so I'm sorry if it's taking longer. I don't know. Maybe I'll... I feel a little tired. Hopefully I didn't pass that yawn to you, but if I did, it means we both need a nap. Your turn. So try it. You got two angles. They're labeled. They're named. The measure, so here's the some math information for you. We know that LMN is twice the measure of NMP, so we want to find the measure of LMN. So we don't know it in specific terms. This is kind of like those like perimeter problems. All right, so what we're going to use is the linear pair theorem. So let's do that and then substitute to get LMN. Let's go M measure, so measure of LMN plus the measure of NMP. Ooh, that's not an M. Again, I gotta work. I gotta practice on this pen more often. It's just a little loose for me. I don't know if that makes sense. Use black. So we know that LMN is twice the measure of NMP. We know that, so we can substitute it. So we're going to replace this with that information. So it's 2 times the measure of NMP instead of LMN plus the measure of NMP. Still equal to 180 degrees because we're looking for that straight angle, and we're using the linear pair theorem, which works on supplementary. Supplementary, you know what that is. Combine like terms, you get 3 of them. So 3 times the measure. I think you should be able to see a pattern of where this is going. What property do you use here? The division property of equality, the DPE. Divide by 3 on both sides. You get the measure of the angle NMP is equal to 60 degrees. We're done, right? What did the question ask, though? Did it ask for that? No, it asked for LMN, so we got to figure that out. Well, go back to your knowledge of linear pair, it's got to add up to 180 degrees. So you could just do 180 minus 60 and get the 120. But you also know, according to this, that LMN is the same as 2 times the measure of NMP. So what's 2 times 60? 120 degrees. And just double check that math. It adds up to 180. Boom. You did a good job, hopefully. All right, so now we're getting into the example 3, explain 3. Postulates about lines and planes, not the planes you fly on. A lot of information for you. There's a lot of diagrams you can put in your notebook. Try to just make your own version. So 302 points, there's always one line. Non-collinear points, there's one plane. If 2 points lie in a plane, then the line containing those points lies in the plane. That makes sense. If 2 lines intersect, then they must intersect in exactly 1 point. Hopefully that you haven't done that with your soulmate. If 2 planes intersect, then they intersect in a line. So imagine like a piece of paper, like slamming a piece of paper, it would make like a line. So just things to know. So here's a figure of 2 planes that have essentially crashed into each other, phased into each other. I like that phrase better. Like Nightcrawler, if he like lands into like a brick wall or something. So the line of intersection, well, that's right there, right? BD. The point of intersection of 2 lines, so where these 2 lines cross would be right there. 3 coplanar points, so that means co is like they're together. Coplanar, they're on the same plane, so like BAD, it's bad. Or you could have had BDE. BDA works too. Collinear, BCD, that's all in one line. So do the same thing here. Slightly different orientation. Don't let your brain play tricks on you. So pause and go ahead. 2 planes. We have plane J, plane F. The point of intersection, right there, right? So it'd be at point J. 3 coplanar points. It could be F and J and H. That works. And 3 collinear points. Well, you got this line, you got that line. So FJG works for me. Let's keep rolling. We got some problems for you guys to reflect on. They think we're in a classroom. That's funny. Your house. What are things that illustrate these postulates? You got walls and floors and desks, tables, things like that. 10, draw a diagram of a plane with 3 collinear points and 3 non-collinear points. So do it, pause. 3 collinear points, they make a line. 3 ones that don't, and then make sure it's all on a plane. I'm not going to draw that because I think you guys can do that. Good question here. So try these, again, as always. What's the difference between a postulate and a definition? Give an example. Well, a postulate is generally like accepted. It's widely accepted. It's known as a true statement, whereas the definition is just a statement that explains the meaning of the word using like other accepted words. So like an example would be like the reflexive property. That's the one where like x equals x. Whereas like a definition would just be like an even number is a number that's divisible by 2. One is, they're not the same thing, I guess is the best way I can describe that. Let's take a look. Example of a diagram illustrating the segment addition postulate. So we kind of did one of these, just end up making like a segment and then another segment. You draw a line through it if you wanted to, make sure points, no biggie. How many of you guys are photographers? Something I would always kind of wanted to get into, but I haven't. Why do they use a tripod? Well, if you think about it, they're using 3 what? Non-collinear points, and it makes a plane so that no matter how they adjust, it's going to give them a flat surface for their camera, which is important. When I vlog, I usually have a tripod. Right now I just got my webcam hooked up on my bezel of my laptop, but I put it in my Amazon wish list. I'm gonna work on getting one. It's like those like clip arms, and it's like a snake, and you can just stick the webcam on it. I think that'd be nice. What are some of the reasons you can give in proving a statement using deductive reasoning? Facts, definitions, postulates, properties, previously proven theorems. So anything that is known and accepted lets you prove it. So to keep that in mind, use things that are already true. So like a question is, how can you use deductive reasoning to establish a conclusion? Well, you provide a logical sequence of statements, and you can support it with, the postulates and the theorems, and each statement follows the next one. So it's like this, and then this, and then this, and then this. It's like why they ask people for alibis, because like they'll map out the day. Like first they did this, and then they did this, and then because they did this, they had the intent to do that, and then they did that. My girlfriend loves watching crime shows and stuff. So first 48. All right, so here's some practice coming up. I don't want you guys doing a lot of this. I think I marked it in the chat, but or in the chat in the playlist. But you can do what you want to do. We'll talk about it in class. But like let me see if I can pull it up. Nah, I don't got it. So I'm just gonna scroll through, and then you guys can figure it out later. So if you want to, like, for some reason you don't have your stuff, you can pause this, get the problems that you want. These ones are probably good to help you figure out the conditional statements. I'm pretty sure I assigned these. There's these ones. Again, I'm just going to let you pause it to get them. 21, 22, I know I did. 23 through 26. I know I talked about 26, but the other ones are good too. That's a thinking question. This is a 2-column proof. That's really common. We'll use them, but a proof doesn't have to be super formal. I think that's something that I want you guys to know. All right. Let me see. Did I cover everything that I wanted to? Make sure you guys know your vocab for this, the examples. Again, I don't expect you to be an encyclopedia, a library of all these things. It's too much, but you need to be able to use your brain to logically deduce things, to prove inductive reasoning, and to prove with the deductive reasoning, and back up your conditional statements. So with that being said, if you got any questions, comments, concerns, hit me up. Hit that subscribe button if you're not already subscribed. If you have a personal account, you should probably be subscribed on that, because you're going to need math help. And the way this is going, I'm going to have a library of content. So yeah, Mr. Answer 4. I'll see you guys next time. Thanks for being here.